Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. In this short video, another video in our series of videos dealing with logarithms, we're going to have a look at another example of solving a logarithmic equation. So this is going to be another example on solving a logarithmic equation. Okay, and I suppose this is example two. This is example 2. So maybe what I should do is I should present you with the logarithmic equation first of all that we want to solve. We want to solve for x. Okay, the logarithmic equation looks something like this. It's log of x. Sorry, it's log of x to the base 3 plus 3 times log of 3 to the base x. Which is equal to 4. And what we'd like to do is we'd like to find solutions of this equation, values of x that make this particular equality true. Okay. Now, in the last example 1, when it came to solving a particular logarithmic equation, the important thing that we noticed was that all of the terms, okay, that had logs, that the bases of the logarithms were all the same. Now in this particular example, what we can actually see is that this particular term here, okay, is log of x to the base 3. So the base of this term is 3, whereas this particular term here, which is 3 times log of 3 to the base x, its base is x. So we have terms that have different bases. Okay? Now there's one of two things that we can do here. Well, I suppose there's one thing that we could do here is we could use our change of base formula. And just remember that our change of base formula, okay, says that log of, let's say, b to the base a is the same as log of b to the base c divided by log of a to the base c. Okay, so we can change bases. We can introduce a new base, okay, by using this particular expression. And we have a video that proved this particular identity. Okay, it's an earlier video in this particular playlist. Okay, so the choice now is this: which base should we convert to? Should we convert to a new base, or maybe should we convert to one of these existing bases? So we could convert to base 3. Okay, well, we don't no conversion to do here. This is already in base 3, but we could convert this logarithm here to base 3 if we wanted to. Okay, or we could convert to base x. I'm actually going to take the base x approach just so that you can actually see what happens. Okay, so what I'm going to do here is I'm going to say, okay, let's consider log of 3 of x, okay, and let's change this logarithm, okay, let's change this to the base 3. Okay, so I'd like to change this logarithm to the base 3. So, well, if I want to convert this to the base 3, it's simply log of 3 to the base 3 divided by log of x to the base 3. Okay, and just note, and there's a proof of this, small little proof, that log of a to the base a is simply equal to 1. Okay, actually the definition of a logarithm is what power should we raise the base to in order to achieve this value. Okay, in other words, what power should we raise the base a to? What power should we raise the base a to in order to achieve this value a? And clearly this value must be equal to 1. Okay, so that's why the log of any number to the same base is equal to 1. Okay. So actually in this particular situation here, what we get is this is the same as 1 over log of x to the base 3. Okay. So what we'll do now is we just substitute this back into our original expression. Okay. So what we have is we know that log of x. Okay. Well, I suppose log of x to the 3 plus 3 times log of 3 to the base x is equal to 4. Okay. So, well then, with this substitution, considering this particular, I suppose, let's say relationship, that log of 3 to the base x is the same as 1 over log of x to the base 3, and substituting that back in for log of 3 to the base x, okay, this becomes, so therefore we have, this implies that log of x to the base 3 plus 3 times log of 3 to the base x. So that's 3 times this particular fraction or quotient here. So that's equal to 3 times 1 is 3 all over log of x to the base 3 is equal to 4. Okay. Now, What we're going to do now in this particular situation, okay, is we could multiply across by log of x to the 3, okay. Maybe what we'll do is we'll just do that, okay. So this implies that log of x to the 3 squared, okay. Now that's not the same as log of a to the n to the base b, if that makes sense. It's not a power function, this isn't, okay. It's the square root of that, okay? Plus 3 must be equal to 4 times log of x to the 3, just multiplying across by log of x to the 3, okay. Well, then this implies that what we have is we have log of x to the 3 squared minus 4 times log of x to the base 3 must be equal to 3, okay. Oh, sorry, plus 3 must be equal to 0, okay. So actually what we actually have here is a quadratic. It's a quadratic in log of x to the 3 is, okay. So what we do is let's just change the indeterminate here across this particular quadratic, okay. So let's just say let's say for argument's sake let y equal log of x to the 3, okay. So when we let y equal log of x to the 3, okay, what we now have is that we end up with that this becomes, so therefore we have log of x to the 3 squared minus 4 times log of x to the 3 plus 3 equals 0 implies that y squared minus 4 times y plus 3 must be equal to 0. So we have a quadratic here, okay. Solving this particular quadratic, I suppose what we end up with y, but this is going to be y minus 3 times, I'm not doing solutions of quadratics here, so let's just jump in, y minus 1 is equal to 0, okay. So therefore we have y is equal to 3, or we have y is equal to 1, okay. So we've solved this particular quadratic here, which is the unknowns are y's, okay, and we found out what the y values are. But what are the equivalent x values for this particular equation here? So what we should do is we should substitute these back in, okay, to what we know. Well, we know that y is equal to log of x to the 3. That's what we let y equal to. So we can actually solve these particular things when y is 3 and when y is 1. And let's see what we have, okay? So let's just recall. Just have a look at this here, okay? So recall, okay, that y is equal to log of x to the 3, okay? So when y is equal to 3, okay, we have that 3 must be equal to log of x to the base 3. Now, what does a logarithm mean? Well, log x to the base 3 is what number should we raise 3 to, what power should we raise 3 to in order to achieve 3? Okay? Well, so what we actually have here is that we need to figure out, okay, what number should we raise, what power should we raise 3 to in order to achieve x? And what we know is that log of x to the base 3 is equal to 3. Okay? In other words, if we raise 3 to the power of 3, we should get x. Okay, so what does this tell us? So this tells us therefore that we have 3 to the 3 must be equal to x, which tells us then that x is equal to 27 in this case. Now when y is equal to 1, we know that 1 must be equal to log of x to the 3. In other words, 3 to the power of 1 must be equal to x, okay? So therefore, okay, we have that 3 to the power of 1 must be equal to x, or what we're saying is that x is equal to 3. And there are solutions, okay? So these are two solutions. So the solutions, okay, are x is equal to 3 and x is equal to 27. There are solutions to this particular logarithmic equation. Okay guys, once again this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and hopefully that it was helpful for you. Okay, and thank you for watching. Okay, bye bye.